Questions? It's about as low level as we'll get. Yeah?
Why do you have to go through assembly code and then the machine code? Why not just go straight to machine code?
Good question. Why do you have to go from one step to another, like from a source code to assembly code to machine code? You absolutely could. It just happens to be the case that there's lots of humans in the world and lots of people working on different projects. And this notion of layering your software on top of someone else's, on top of others, allows us to build more complex systems much more cleanly, if you will. And there's different types of computers in the world. There's Macs, there's PCs, which even though these days they're a lot more similar underneath the hood, literally, than they used to be back in the day, there's different CPUs. There's phones that have very different CPUs. And wouldn't it be nice if I could write my programs in one language and compile them into zeros and ones that do work on a Mac and on a PC and on an Android phone and an iPhone and so forth. And that's why by having these sort of different layers, one set of humans or one person can implement the process of converting C to assembly code. Then someone else can take it to the zeros and ones in some sense. Or there's even intermediate steps. Compilers have front ends and back ends and all of this complexity. But it gives us advantages because it means we can sort of decide which types of hardware to support more easily. Really good question. Other questions? OK, so with that said, let's now consider any number of ways in which things can go wrong. It's easy for me, certainly, to like write hello world and everything just kind of works. And even when it doesn't, I quickly know how to fix it. And it's only from experience and practice. But let me just give you a teaser, not just of Help 50, but two other tools that you'll see, particularly for the problem sets, that will not necessarily teach you how to write good code, good efficient code. That's where the humans come in and the teaching fellows feedback and sections and office hours and more. But at least to write correct code that meets our specifications and that's well styled. It at least looks good. But the third ingredient, recall, besides correctness and design, correctness and style, is going to be design, which is something we'll learn after practice and examples. So with Check 50, this is a tool that comes in CS50 IDE, recall if unfamiliar, that allows me to essentially do this. Let me whittle this back down to my simplest hello world program like this. I no longer need the CS50 library. I can run make hello. Seems to work. And how do you go about testing your programs if you've written this for a problem set? Well, the easiest and most straightforward way, of course, is just run it. Looks like it's correct. And it is. And there's not too much that can go wrong in this program. But soon you'll see with problem set 1 and beyond, anytime you start getting input from the user, where he or she has to type their name or a number or other things, you can absolutely concoct scenarios where something goes wrong. But if you run a command in this case, like check 50, we can do the following. Let me go ahead and first make a directory called let me go ahead and do this and do make dir for make directory hello. And then we didn't see this the other day, and you'll see more of this in today's super sections or class-wide sections, which will also be filmed. I'm just going to move this file into a directory called hello. So that's like on a Mac or PC, just dragging and dropping it. But I'm doing it with my keyboard. What's the command to change into another directory? CD. So that's like double-clicking on a directory, albeit with my keystrokes only. And now I'm going to go ahead and run this. I can run make hello again. Seems to work. And I can run /hello. Seems to work. But now let's see if CS50 agrees. So check 50. And then I'm going to type CS50 2017 fall hello, which looks like a bunch of folders, but it's not. It's just a unique identifier that has sort of some hierarchy to it. You would only know to type this by reading a problem set specification online. And what this is going to do, if you haven't seen it already, is actually connect to CS50 server. It's going to authenticate you if you haven't already. I'm going to go ahead and log in as student50. And now, hereafter, it will remember my password for at least some amount of time, so you don't have to type it in every darn time. Then it's preparing, it's uploading. And what's happening now is my hello.c file is somewhere in the cloud on CS50 servers. We are running the checks, the tests that the staff wrote. And hopefully, I'm going to see a whole bunch of green smiley faces that look a little yellow on this projector, but those are, in fact, green smiley faces instead of frowny faces, which would suggest something is wrong. So that's all good. And don't be discouraged if you see a few frowny faces or a few flat, confused faces if something else is awry. But style 50 does something different. Right now, the style of my code, I'd argue, looks pretty good, because it's kind of hard to go wrong when it's this short, but we'll see a way. And if I instead run style50 hello.c, just the name of the file I want to check, looks good, but consider adding more comments. And that's pretty compelling, because there's 0 at the moment. And so what kind of comments might you want to add? Well, in this program, you know, it's not that compelling to add that many comments, because the reality is this program is so short, it's probably takes me less time to read the code than the comments. But it's very common, as you'll see in the examples from lecture, to do something like this. Says hello to user. Just a quick one-line summary so that when you're skimming the file or looking at the code, OK, I got it. I know what this does. And if I care to know how it does that, then I can read the code. And so that would be a comment, and that will probably make style 50 helpful in this happy in this case. But what if I'm getting a little sloppy and I remember vaguely that I was in the habit of hitting tab or the space bar in lecture, but I can't be bothered to do that when I'm working on my problem set. I just want to get the darn thing to work. It's not uncommon for code to eventually start to look like this, even though this too is a simple program. Now, good style, as you'll see and learn from practice, dictates that just like in Scratch, there were those yellow puzzle pieces that kind of hug the code. Similarly, inside of curly braces, you really should be indenting. And so if I go ahead and sort of forget that and now run style 50 on hello.c, I'll see my code outputted in the terminal window, the bottom of the screen, but green suggests, hey, programmer, add the following characters. So green suggests add here, and if I go ahead now and re-indent that by hitting tab, specifically 4 spaces, which is a human convention, it should make it happy again. We can go in the reverse direction, though. Suppose that I got a little confused as to what I actually am supposed to indent. And you might even see in textbooks and some online resources, some people write their code like this. Let me go ahead now and run style 50 on this. It's going to print out my code. And red, in this case, means remove those characters that you might not otherwise see. So it's not always going to be perfect, and especially when the programs get long, might be a little non-obvious what changes you have to make. But just like with error messages, start at the top, make one or few changes, save it, and rerun it, and see what the updated advice is. And I can't stress this enough, especially with problem set 1 and any problem set thereafter. Don't get into the habit of sitting down and trying to bite off the entirety of a problem. Odds are with Scratch, you didn't sit down and write the whole thing without once playing it or testing it or adding features to it. Don't get into that habit. Then in C, take steps and steps, just as we've been doing with these examples so far. All right. Any questions then on those tools? And we'll come back in just a moment to more sophisticated debugging techniques. All right. So one of the problems that, as we were distracted by earlier, is there's this old school game, Super Mario Brothers, wherein a character like this jumps around the screen quite a bit. And it's one from the very first Nintendo game. And there's lots of obstacles in the way of Mario as he's running left and right and jumping. And some of these obstacles can be represented with fairly simple constructs like bricks in this colorful world, and we can approximate this just by using characters on our screens as well. So I actually poked around for far too much time last night looking at old Super Mario Brothers maps, which if I had them in like the 1980s would have made Super Mario Brothers a lot easier. But people have captured all of the imagery from this game, and one snapshot from this game was a screen like this. So eventually Mario's supposed to run through this, and he's supposed to bump his head up against the question marks and get coins and so forth. But for now, I'm going to really, really simplify this and propose that all I care about for the sake of discussion is this line of question marks. How would a computer program, whether in Super Mario Brothers or today here in Sanders, go about printing like a line of question marks in a row like that? Well, let me go ahead and open up CS50 IDE. I'm going to go ahead and create a new file here. And I'm just going to go ahead and call this, say, Mario0.c, because it's the first or 0 version of this program. And I just want to print like 4 question marks. So let me take a stab at this first. So include standardIO.h, which I think I need because why? Yeah, I need printf. I need to be able to print the character. So int main void is what comes next. And we'll start to tease apart why that is today. And now I'm going to go ahead and print out question mark, question mark, question mark, question mark, and then semicolon. All right, let me go ahead now and make Mario0 ./Mario0. And I kind of sort of have a very ugly textual representation of a really fun, at least 1980 style game. But there's a slight aesthetic bug, and I made the same mistake the other day. How do I move my cursor onto the next line? Yeah, so \n. So \/ is the one we're about to type, and / or / is what people would call just the other direction. So that's \n, and that's a special escape character, so to speak, right? It's for now, just know that this starts to confuse the computer if you just like literally hit enter. Like now your code's on 2 lines when really it's just one idea or one function. So humans decided some time ago, let's just represent that special character that you would otherwise just hit on a keyboard. So now if I rerun make Mario 0, /Mario 0, OK, now it looks a little better. But we know from scratch that we don't just need to do question mark, question mark, question mark, question mark, especially if I want even more coins to be available on the screen. What's the right programming construct to just give me more of these? Yeah, like a for loop, right? So let me go ahead and tweak this a little bit. Let me go ahead and in, let's say, Mario1.c, so Mario1.c, I'm going to instead do this. So for int to give me an integer, I equals 0 by default, though it could be 1, but programmers tend to use 0. I is less than, I'm not sure, so let's just put a big blank there for a moment. And then I++, I remember, being the way to increment. And then inside of this loop, I'm going to do printf question mark semicolon. And now let's answer this question. If this for loop, which recall has a very methodical process to it, it initializes, checks the condition, does something, increments, checks the condition, repeat again and again. What number should I put on the otherwise blank line here? So 4. But if I'm counting from 0 to 4, that feels like it's 5 numbers. So 3 might get me closer, but less than. We have this relational operator. Less than could have been greater than in other contexts. So the less than actually saves us. If I do 4 here, think about logically what's happening. I gets initialized to 0 for the first time, and we get a question mark printed. Then it gets ++, and so it becomes 1, which is less than 4. And so that's the first time I printed a question mark. Then I becomes 1 next. I print another one. I is now 1. I do another. I is now 2. I do another. I is now 3, which is not consistent with the number of fingers I'm holding up because I started at 0. But once I becomes 3, and therefore I've already printed my 4 question marks, the next value I is going to take on is 4 itself. Is 4 less than 4? No, so I never get a chance to print another question mark or put up another finger. And honestly, this is like a waste of intellectual capacity to like think through, OK, how many numbers are between like 0 and 4? We could have, like most of us in this room just think, could have just done I is less than or equal to 4, and that too would have worked. This is even more clear, perhaps. You start at 1, and you count up to and through the number 4, and that will give me 4 fingers as well. Why do we start counting at 0? It's kind of just because, but more technically, it's because it's easy to start counting with all 0 bits per our first lecture. So it's just a habit. And it's fine if you're more comfortable this way, but before long, get into this habit just because everyone else does it this way. OK, so now let's go ahead and print this out. Make Mario1 /Mario1. Still that bug. OK, is this going to fix this? Why not? Yeah, that's going to do question mark, new line, question mark, new line. That's not right. So what line number should the \n really go on or between? OK, so it should go outside the for loop. So specifically, I saw a hand in back too. What line number? Yeah. Yeah, so like between 8 and 9. There's no room there at the moment. That's no big deal. We'll just hit enter, printf, and I can certainly just do a single \n even with no words to the left of it. That too is OK. Let me recompile this. And honestly, if you get bored retyping the same commands, know that you can also hit up and down on your keyboard, and it will go through your history, so to speak. And that too, over time, will start to save you time. So there's make Mario1, enter, /Mario1. Or I could just scroll back up as I did before, and now I get those 4 question marks. But now let's actually create this a little more interestingly as follows. Let me go ahead and not just hard code 4 into this program. Let me make one more version of Mario, call it Mario2.c, and this time actually get some user input. How about I do int n, because n is like a number, and it's just common convention to call it that, get int, and then I can say number, semicolon. And now instead of hard coding 4, why don't I just put n there, which I can certainly do. So let me go ahead now and run make Mario2. Uh-oh. Error. Yeah, I forgot cs50.h. So I have to go back up here. I'll just do a quick copy, paste, and then change the word, cs50.h. Now I'm going to clear my screen. And to clear your screen, you can hit Control L, for instance, which just keeps fewer characters on the screen for us. Make Mario 2. That worked. I didn't need to worry about the -lcs50 because, again, make does that for me. That's one of the features. And now I can do make Mario 2. Number, how many question marks do we want? So I heard 7 first, and now we have 7 question marks. And it's not necessarily going to look super pretty. If I do 700, now I'm going to get a whole lot. But look how quickly it did that for me. And so we have this power now of loops. So that's good. But you know what? I'm a little, let's see. What about this? What about -50 question marks? Is -50 an int? It is. So we will get it for you via the getInt function. But that's not really logically what we want. So think about it. On line 7, if n equals -50, how many times will the for loop execute? Why none? Yeah, because 0 is, in this case, greater than -50. So that condition never lets the loop actually proceed logically. So we're kind of OK. Nothing seems to happen. I get this sort of ugly blank line. And maybe that's arguably a bug. But at least it didn't like freak out the computer and just kind of print things infinitely many times, as could actually happen. So let me go ahead and actually, let's, well, the risk of losing control over my computer. Let's go ahead and change the logic. Suppose I change the less than to a greater than, and we initialize n to -50. And now is 0 greater than -50? Yes, and it's going to be that way for like a really long time, most likely, right? Even as you increment it. And so let me go ahead and do make Mario 2, and then hold my breath, and do -50. And like even the internet and the computer can't really keep up. And that's why you're just kind of seeing it bursty like this. We're sending thousands, tens of thousands, millions ultimately of question marks across the screen. And that, too, you might do accidentally. And so just as I did, you can hit the secret keystroke, which usually works, which is Control-C for cancel. And that will stop a program in the window from running. All right, so I've gone ahead now and implemented kind of a very weak approximation of this. So that's great.